Hello and welcome to the Detroit Training Center. In this video, we're going to perform the differential setup on this 9.5-inch axle. This axle can be found in Sierras and Silverados. Before we start axle disassembly, we need to make a few measurements. The first measurement we'll do is the turning torque of the axle. Using an inch-pound beam-type torque wrench, we're going to rotate the axle and record our measurement. In this case, we have about 16 inch-pounds of rotating torque. Our next procedure is to measure the axle end play. We do this with a dial indicator. As you can see, I have the dial indicator set up with the tip on the back of the axle flange. Pushing the axle flange in all the way, which it already is. Now I need to zero the dial indicator. With that set, now we pull the axle out. And there's our axle end play, 11 thousandths, which is within spec. The other axle was within spec as well. I'm going to go ahead and record these results. The next step before axle disassembly is to check ring and pinion backlash. To do this, as you can see, we need a dial indicator. The tricky part about this is that this center section of the axle is aluminum, so we can't put our magnetic base on it. I went through and found a bracket that I can bolt to the housing. Then I mounted my dial indicator base to the bracket and set up the dial indicator as you see. One note is that you don't want to use very long extensions. You want to be as close to what you're measuring as you can be. Long extensions can cause inaccurate readings, so just be aware of that. At this point, we need to zero our dial indicator and take our measurement. While holding the pinion, I will move the ring and gear back and forward and then zero the dial indicator. Now I will move the ring gear. As you can see, we have about 8 thousandths backlash. Now we measured this in several different spots, and both our consistency was within specification and our backlash is also within specification. Our final procedure before axle disassembly is to check the ring and pinion gear tooth pattern. To do that, we'll need some gear marking compound, as you see here. We will need a stiff brush. We will apply the compound to multiple locations on the ring gear. When applying the gear marking compound, make sure to apply it on the drive and the coast side of the ring gear, as well as be sure not to put it on too thick. It may affect your readings. As you can see, here's our gear tooth pattern for both the drive and coast sides. We compare this to the gear tooth contact pattern inspection document and service information, and we have a good gear tooth pattern. With the preliminary checks complete, we need to start disassembling the axle. To begin, remove the pinion gear shaft lock bolt, which in this particular case, it hits up against the cap. So we're going to pull it out so it's out of the way. Then we're going to push the pinion gear shaft towards us so that we can remove the pinion gear shaft. It's now time to remove the axles. To remove the axles, push the axles inward and remove both axle shaft locks. In this particular case, I find it easy to use a magnet to do this. Now, in some cases, it may be necessary to reposition the locking differential thrust block to allow the axles to move in far enough to remove the axle shaft locks. With both axle shaft locks removed, we can now remove the axle away from the differential carrier. Before removing the differential bearing caps and bolts, we need to mark the caps to make sure that they go back on in the same spot. With the differential caps removed, you can now remove the differential assembly. With the differential assembly removed, remove the shims and be sure to mark them left and right. To remove the differential side bearings, we'll use a universal 2-jaw puller and the pilot. With this side complete, we will flip it over and remove the other bearing next. Before we remove the pinion flange, we need to check our pinion preload as we now have the differential out of the rear end housing. To do that, we'll use our inch-pound torque wrench and rotate the pinion. This gives us about 10 inch-pounds. We will record this as we did the other measurements. To remove the pinion flange, we first, of course, need to remove the pinion nut. We need to mark the pinion flange and the pinion shaft. We now need to install the pinion flange holder and remover. Snug the bolts for the pinion remover. Okay, now we'll remove the differential drive pinion gear seal, and we will then remove the differential pinion gear outer bearing. And then we will remove the pinion gear. Since we are not replacing the differential drive pinion inner bearing and the outer bearing, we can reuse the differential drive pinion inner and outer races. Now we need to remove the drive pinion gear bearing spacer, and to measure pinion depth, we need to remove the inner bearing off the pinion. To do this, we'll use a shop press and a bearing remover, as you can see. Follow the cleaning and inspection procedure for the differential components and housing. To be specific, look at the cover, differential carrier bearings and pinion bearings, and inspect the housing for any nicks, burrs, or issues with the bearing races. Now we need to determine the correct pinion shim needed to provide the correct pinion depth. With the differential drive pinion gear bearings lubricated, we need to install the pinion bearings and special tool into the rear axle. However, before we do that, let me show you the setup on this special tool. With the rear pinion bearing removed, you can see that we have the gauge block, the stud, and the front and rear pilot shims. The pilot shims mount inside the inner race and keep the bearings centered. With the rear pinion bearing reinstalled, we now install the assembly into the housing. We install the front pinion bearing over the pilot shim. We install the washer over that and the nut. With the nut installed, we now need to tighten the nut until we obtain 33 inch-pounds of rotating torque. We're going to use our inch-pound torque wrench now to check our preload or rotating torque. It calls for 33, and coincidentally we have 33. SI then suggests that we rotate the assembly a couple more times to get the bearings seated and then recheck. And we have 33 inch-pounds. Now it's time to install the arbor assembly. Before we install it, we need to check that the plunger moves freely and returns to its original position. With that verified, it's time to install the side discs and verify everything still moves freely. Once we have verified that, it's time to put the assembly into the housing with the side discs lining up on the housing inside edges. Now it's time to install the differential main caps. And tighten the bolts to spec, which is 44 foot-pounds. With the last main cap bolt torqued, we need to verify again that the arbor assembly rotates freely within the housing. And as you can see, it does. SI now directs us to put the plunger on the gauge block, and then we need to install the dial indicator to contact the plunger. Once it contacts, I like to zero the dial indicator like so, and then SI directs us to preload the dial indicator to about 3/4 of a turn, or about 75 thousandths is what I prefer. Like so. Now we need to zero the dial indicator again. We need to move the arbor assembly until we get the greatest deflection, which is about there. Zero the dial indicator. And then SI tells us to move the plunger off of the gauge block. Now when you do this, you should hear a click of the plunger hitting the arbor assembly. If you do it quick enough, you probably will hear the click or the contact. The value or reading indicated on the dial indicator set, not the amount of movement of the dial indicator, is the thickness of the pinion shim needed. In this case, as the dial indicator indicates, we need a 39 thousandth shim. So we're going to put the shim onto the drive pinion gear, and now it's time to press the drive pinion gear inner bearing on. to the pinion. So we'll install our special tool, place the pinion gear in place for the press, and press the bearing on. At this time, we need to install a new pinion gear bearing spacer onto the pinion. This is sometimes called a crush sleeve. And since we didn't replace the inner or outer pinion bearings, we can reuse them and the races that are already in the housing and install the pinion gear. We have installed the outer pinion bearing. Note, this may be an interference fit. With a new differential drive pinion gear seal installed and sealer on the pinion gear splines, we are going to install the differential drive pinion gear yoke. Remember to match the splines that we marked earlier on both the pinion gear and the yoke together when installing on the pinion. You may need to use a soft face hammer to get the pinion flange on. As you can see, we've installed the holder onto the pinion flange. We've installed a new pinion nut and got that hand tight. We will now use this 4-to-1 multiplier, install the pinion nut the rest of the way. The 4-to-1 multiplier is necessary because collapsing the pinion bearing spacer can be really difficult. So getting an advantage using the 4-to-1 multiplier greatly helps us. So we're coming up where I need to check the turning torque again. So let me remove this tool. We're also going to remove this tool. Because this heavy flange remover and holder tool will affect our readings, so we need to get that off in order to make an accurate preload reading or rotating torque reading, whichever you prefer to call it. SI states for this SU8 9.5 inch rear axle, we need 10 to 20 inch-pounds of pinion preload or rotating torque. We have 15 inch-pounds. Since SI suggests that we rotate the pinion a few more times just to make sure the preload is accurate. So we've done that. Now we'll put the inch-pound torque wrench back on. We'll recheck. And we still have 15 inch-pounds, which is exactly what we need. With the pinion preload correct, we now need to stake the new pinion nut. And we have to do it on both sides of the nut. Now we need to install the final differential side bearing using the J29710 special tool. As you just saw, we have the correct pinion rotating turning torque of 15 inch-pounds. And you can also see now that I have the differential assembly in with the bearings and the bearing cups or races, if you like. So now we need to install the 40 thousandths bent service shim that we have here onto the right side. The 40 thousandths shim is a technician-made shim that can be bent on the edge of a table or in a vise, like so. The bent shim acts as a spring and takes up space. And then we need to move the differential assembly over as far as we can get it so that we have zero backlash. Quite like that. Once we have the zero backlash, then we can install the 211 thousandths service spacer onto the left side. With the service shim in place, we now need to add shims per SI until we have no backlash between the ring gear and the pinion gear. As you can see, we just added a shim and we no longer have any backlash. So we're good on the left side. Now that we've finished with the shims on the left side of the differential, we need to remove the bent shim on the right side of the differential. And we need to install a 211 thousandths thick service shim into the right side of the axle housing. We also need to add an additional shim that requires moderate pressure to install. Now in some cases, you may have to tap that shim in. Like so. As you can see, we removed the differential assembly and the shim stacks. So our left shim stack, our inserted shim measures 68 thousandths. Our right side shim measures 40 thousandths. So SI prefers us to subtract 6 thousandths from the shim on the left side and add 14 thousandths to the shims on the right side. So we will, on the left side, we will replace our 68 thousandths shim with a 62 thousandths shim. And on the right side, we will place our 40 thousandths shim with a 54 thousandths shim. Now it's time to install our shim stacks, our new shim stacks with the different shims in it. This is, of course, going to allow us to set our initial preload and backlash. Now we are directed to torque the main caps to specification, which in this case is 44 foot-pounds. And then we are directed to rotate the pinion to seat the bearings. You can also hear the backlash between the ring and pinion now. So we know we're kind of halfway close anyway. At this point, we now need to measure the preload of the drive pinion and differential case side bearings. According to the axle preload and backlash specification document in SI, the specification is 28 to 45 inch-pounds when using used bearings. In our case, we have 37 inch-pounds of preload or rotating torque, which is within specifications. What I want to say is if you need to change preload, you should increase or decrease shim thickness to both sides equally. We just performed the shim method to determine the backlash and the side bearing preload for the differential carrier. There is an alternate method called the wedge method. This method uses the J22 779 side bearing backlash gauge. This multi-step procedure includes the use of this gauge to determine the left and right side bearings shim thickness. To use the side bearing backlash gauge, you would install it between the bearing cup and the housing. You could then loosen or tighten accordingly until you have moderate resistance when removing the backlash gauge. Once removed, you would then use your dial calipers or your micrometer to measure this in 3 different places. Once you have your measurements, you would then average those measurements, and that would be the size of the shim stack for the right-hand side. You would then do basically the same thing on the left side to obtain the size of the shim pack for the left side. Now that we have the correct preload, we need to check our backlash. As you can see, we have our dial indicator installed, and we need to zero that dial indicator. Once zeroed, we'll move the ring gear up, back and forth, and as you can see there, we have about 7 thousandths, which is within the preferred spec of 6 to 8 thousandths. So our backlash is good. Now I will also tell you that we checked this in about 8 different spots, and our results were within specification. We have rechecked the gear tooth contact pattern, and as you can see here, the coast and drive patterns look good. If you had an issue with either pattern, you should reference the gear tooth contact pattern inspection document in SI, which will give you suggestions on how to fix your pattern. For final axle assembly, SI directs us to confirm that our side bearing cap bolts are torqued correctly, which we have done, and they are. We also need to check the pinion and differential rotating torque, again, which we have done, and it is within specification. We have the axle shafts installed, and now we need to install the axle shaft locks. With the axles in position, pushed in, we can put the axle shaft lock in, then we pull the one axle shaft out, push the other in, and we will install the other axle shaft lock. Like so. We now need to install the differential pinion gear shaft. And tighten the bolt. And we're going to tighten the bolt to specification. With the differential pinion gear shaft lock bolt torqued to the correct specification, our last component to install is the axle housing cover. Once finished, Don't forget, you need to add the correct axle fluid and the correct amount. As you can see, there are some difficult steps in this process. Make sure to follow SI for a successful repair.